Inverse hyperbolic functions. So let's take a break from calculus for a second and let's do an algebra problem. We're given these three functions, and this is what they are. Inverse hyperbolic sine of x is equal to the natural log of x plus the square root of x squared plus 1. And you can plug in anything you want to. That was because the range of just sine hyperbolic was all real numbers. Well, in our problem, what we're going to mess with today is we're going to show that cosine hyperbolic inverse of x is equal to the natural log of x plus the square root of x squared minus 1, with our x value being greater than or equal to 1. And that's because, remember when we made our graph at the beginning, the range of cosine hyperbolic, not its inverse, but cosine hyperbolic, was from 1 up to infinity. And when you find an inverse, you swap your inputs with your outputs. Speaking of which, let's go show this. We want to show that cosine hyperbolic inverse of x is equal to the natural log of x plus the square root of x squared minus 1 for only x values that are 1 or larger. So let's do this algebra problem. Let's get into it. Fun with algebra. So we're going to say that we have e to the x plus e to the negative x all over 2. And let's set that thing equal to y. Well, let's do this a little bit backwards. Let's say this. No, a little more. Y equals, right? So that would be for cosine. But if we wanted to find cosine inverse, well, shoot, wouldn't that be that x is equal to e to the y plus e to the negative y all over 2. Swap your inputs with your outputs. You remember this? This would be like step 3 of your, or step 2 of finding your inverses. So that's all we did is we swapped our inputs with our outputs. There we go. There we go. All right. So let us get it. So we're going to need to go solve for that y, get it all by itself. That would have been the game when finding it in a typical algebra class. So let's move the 2 over to the other side. Now we have 2x is equal to e to the y plus e to the negative y. Well, let's get everything over to one side of the equation. So let's move this 2x over, but I want to move it right into the middle. This is going to be very similar to that one problem that we had done in our review before our last exam. We have this e to the negative y. We don't like it very much, so we're going to multiply both sides of this equation by e to the y, just so we can get it. We can get that e to the negative y. Because that's 1 over e to the y. We don't want variables in denominators. That's bad. So we take our e to the y, we multiply it by 0, and well, that's still going to be 0. We take our e to the y, and we multiply it by e to the y, and once again, that's not e to the y squared, that's e to the 2y. Next, we have our e to the y times that negative 2x. And now we have e to the y times e to the negative y. That's just equal to 1. Well, allow me to write this a little bit different. We have the same sort of trick that we had in a previous problem. Let's just for a moment, instead of calling e to the y, let's call it z. Let's let z equal e to the y, just so possibly we can see what's going on here. So we have z squared minus 2x times z plus 1. Well, if you could just imagine that x wasn't there, wouldn't this be kind of like a quadratic? Where I think if we list these things out, we could say that our a is equal to 1, right? Our b, let's call it that negative 2x. Let's let that hang out. And over here, we'll call that our c is equal to 1. So there was our a, there was our b, there was our c for the quadratic formula. So we can say that our z value is going to equal, what is that? That's that, it's negative b, so negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so what do we got here? This is equal to positive 2x plus or minus, and then we get 4x squared minus 4 all over 2. Let's continue to clean this thing up, and Well, shoot. Look at that. There was a 4 in common. So we could have factored out that 4 and the square root of 4. Well, that's just equal to 2. Well, since we're here, let's factor out the 2. And I feel like we're almost there. And a little, hey, they're gone. What do we got? We got x plus or minus the square root of x squared minus 1. Well, sweet. Well, sweet. Well, what's going to be our answer? Is it going to be the plus or the minus? Or do we just use the formula for above and that's going to tell us it's the plus? Well, the issue is we can't allow this thing to be negative. It needs to be the positive due to our domain restrictions. We cannot use this thing or else we're going to end up with values we're not allowed to have. Hence, we're going to end up with x plus root of x squared minus 1. So that was what our z was equal to. But that was z, that was z, that was z, that was z, that was z. But what was z equal to at the very freaking beginning? E to the y. Back there it was equal to e to the y. So let's hit both sides of this thing with a natural log, and we're going to have the natural log of e to the y is equal to the natural log of, that's our x plus squared minus 1. Our y is going to fall to the front, and we're going to have that y is equal to the natural log of x plus the square root of x squared minus 1. And y, well, that was right there at the beginning, and that was cosine hyperbolic inverse of x is equal to the natural log of x plus the square root of x squared minus 1.